In this section, we are going to look at a shortcut of graphing lines using their slope and their y-intercept. Think about the idea of the word slope. We think of ski slopes or slant when we think of the word slope, and that's what we have here. A slope is going to be how slanted a line is. These lines all have a positive slope. This line, well, if I can draw it flat, this line has a 0 slope, and these lines all have a negative slope. This line doesn't have a slope. It's a cliff. You can't ski down that. You'll die. It's undefined. I guess some of those extreme guys might. But we have that as an undefined slope. These are positive slopes, and these are negative. So if you imagine a little skier skiing up these positive slopes, poor guy, he's climbing up there. So, ugh, he's climbing. All the positive ones. These, what's he doing as he goes down these? Whee! Okay, so the negative ones, he's sliding down saying whee, and these, the 0 is sort of like cross-country skiing. So, where they have little tracks and they push themselves across. So that would be the slope 0. Undefined, poor thing. So he can't ski down that. Okay, we use for the slope the letter M. M is the slope. And in an equation, when we have y all by itself, the form of the equation is y equals mx plus b. B is the y-intercept. In other words, where it touches the y-axis. Well, how are we going to use this to help us with the slope? Let's look at one of these lines. Suppose we start here and we go down and over. Notice this line, wherever we are, the ratio of these going down and overs is going to be the same. It's going to be true here, except I'm going to go up and over. So the positive ones, I go up and over, and the negative ones I go down and over. People often call this rise over run. If you're rising down, you're falling. So in this one, the rise would be negative, so it would actually be falling. Run, meaning across, and if the run is positive, I'm going to go to the right. If the run is negative, I'm going to go to the left. Let's look at an example of actually using this to graph a line. Let's suppose we have the line y equals 2/3 x plus 2. The y is by itself, so we have it in the y equals mx plus b form. Right. So this is the m, and this is the b. Remember, the sign goes in front of the number we're talking about, so the plus is part of the b. Okay, so here our slope is 2/3. 2 is positive, so we're going to rise up, and when 3 is positive, we're going to run to the right. But where are we going to start? We're going to start at the y-intercept at 2. Technically, the y-intercept is 0, 2. But if we just think of it as the y-intercept, we don't really need to think about the 0 because the 2 is right here on the y-axis. Now, I'm going to start there at the 2, and I'm going to rise up 2. So I'm going to hop up 2, and we'll run to the right 3. And wherever I end up, that is my next point. And now I can get out the straight edge and connect the dots, or I can do it again and again and again as many times as I want, because the slope stays the same all along. I'm going to go ahead and attempt to draw my line in here and get that line. So I have used the slope and the y-intercept in order to graph this line. Okay, let's look at one where we don't see a fraction for the slope. Y equals the opposite of 2x plus 3, or negative 2x plus 3. But really that is a fraction, isn't it? Because negative 2 is a fraction. It's negative 2 over 1. So the slope is going to be going down, so the rise is really going to be what? Down, because it's negative. The run is still positive, so it's going to be to the right. Where is the y-intercept? 3, so I'm going to start at the point 0, 3, right here. And I'm going to rise down or fall down 2 and go to the right 1 to get my next point. And again, if I want to do it again, I can. Don't have to, but I can keep doing it as many times as I want. So I could go down 2 more and to the right 1. And keep doing that over and over. Let me go ahead and draw my line through here. Oops, I didn't draw. Let me try again. There's my line. So that was a quicker way of drawing a line. Remember, I can use the intercept method when the x and y are on the same side. I can use this slope intercept method. It's called slope intercept when y is on a side by itself. Okay, let's look at one that has an improper slope. 3/2 x minus 4. Maybe give you a moment, pause this, and you graph it and see if you can do it correctly, and then turn this back on and make sure you've done it correctly. Okay, the slope is 3/2, so I'm going to rise up, and I'm going to run to the right, and the y-intercept is -4, so I'm going to start here at -4. I'm going to rise up 3, and run to the right 2. So I'm going to get my point right here. I might also mention that the slope is 3/2, but that's also equal to -3 over -2. So if I had -3 over -2, what would happen? I would cancel all the negatives and get +3 over 2. So that would mean I should be able to rise down and run left. Well, let's notice if we do that from this starting point of -4, if I go down 3 and left 2, look, I end up on the line. So it works. I can go in either direction and just keep on going up and down over. The slope is always the same on the same line. Okay, let's do one more example here where that'll actually come in useful. Y equals -6x minus 8. So the slope here, m, is equal to -6 over 1. And the y-intercept is -8. So that means I should go down 6 and right 1. But look what's going to happen. Uh-oh, I'm running out of space. I can't fit it on this graph. So what am I going to do? Well, -6 over 1 is the same as 6 over -1. In other words, the negative can move. As long as there's no addition or subtraction going on in the numerator or the denominator, the negative can move because -6 divided by 1 equals -6. And 6 divided by -1 also equals -6. So now I've changed it so the rise is up and the run is left. And I will be able to do it. So I'm going to rise up 6, 1, 2, 3, 4, 5, 6, and run to the left 1. So now I can do it. So on occasion, to fit it on the graph paper you have at hand, you may have to change the slope to form. You're not really changing the slope, you're just changing its form. It's still a negative slope. It's still one of the ones where you're skewing down. You've changed its form so that you can better graph it. Okay, in the next one we'll look at horizontal and vertical lines where only the x or y variable is present.